Hello everyone. In this video we will look at networking concepts. Okay, here are the objectives for this video. We'll look at type of networks, we will look at network topologies, and we will look at some of the internetworking devices. Type of networks. First type of networking is peer-to-peer, and the other is server-based. Let's try to understand these types of networks using some diagrams. Take this case where you have a laptop 1, it's in yellow, laptop 2, and we have a desktop. Let's say this could be a switch or a hub. We'll talk about what a hub, what a switch is later. So they're all connected through, via this central device. They are able to communicate to each other, and this is a peer-to-peer network. And the reason for that is no one plays a special role, or no one has any kind of authority to dictate anything on the network, or there's no special role for any machine or any system on the network. Each system can work by itself and will not depend on the others. It may be accessing some stuff from other machines. Say for example, let's say you have a printer here, right? This, let's say that's a bad picture, but let's say that's a printer that's connected here, and let's say this is being shared. That means it's shared so these people can print. So even though this system is trying to access the printer that is shared here, still there is no special role as such. So every system is equal in the network. Okay, no system plays any kind of special role. Now let's take another picture. Look at what a server-based network is. Now take a look here. Here it's a little bit different. It's the same network, same hub switch situation, and you have 2 laptops and a desktop. Let's add something else here. You're going to add something called network server, and there's a printer connected here. And don't get me wrong, a printer you can connect directly here, or there's another way. If this is a network printer, you can directly connect to the network. Or, not here, but here. You can either have this, or you can directly connect here. And now we now configured this system as network printer. Network print server. It's a special role. This system will administer this printer, and these devices now can print to here, but this system will control things in terms of who can print, who cannot print, and things like that. And when the printer can be brought down for maintenance, and anything and everything can be administered from here. That is just one service. Let's say there is another system here, and it has all the documents, and it's connected to the same network. Now these documents are shared so people can access it. Now you refer to this system as file server. So these systems, let's say everything I'm going to mark it as A star, B star, C star, they're all clients. But whereas the systems here, I'm going to call it double A star, double B star, they are servers on the network. That means they have some special role on the network and they provide some sort of service to the network. And these type of networks are referred to as server-based network. And this is a very simple form of network diagram. And when you take a look at a real network, it will be a little more complex. It's not just directly running a cable to a switch next to you. The whole networking in a building is a little bit complex when compared to this diagram here. It's not as simple as it looks. Next, okay, let's take a look at topologies. Okay, here is a list of topologies: point-to-point, bus topology, star, mesh, hybrid, and wireless topology. Wireless is pretty much new ever since they started developing this technology. Now it's pretty common even in the corporates. So let's take a quick peek into all these topologies. It's very easy. Just take 5 to 10 minutes to understand all these. First one, point-to-point. As the name says, it's a point-to-point, meaning it's from one node to another node. So node here to here. So these systems are connected directly using a special cable. This is referred, it's not a regular LAN cable, it is a crossover cable. It's specially designed to connect systems directly, and that's what is point-to-point. Bus topology. These are all logical. It's not that this bus doesn't mean that systems have to be in straight line physically. It could be, this length could be something like this is a curve, and systems could have been connected like this. It is still a bus topology. It's a logical connection. And bus topology, the cable that is used is coaxial. Coaxial is the one that you normally see to connect TVs. The cable TV, the fat thick one that comes to your house, that's the coaxial cable. So that is used, and the way this works is these are called BNC connectors, and the end of the wire, they are called terminators. So there's a wire and there's a T-shaped connector that is used to connect a computer into this main cable. If they had to, let's say you have 4 here, let's say you need another 5th computer connected, you really have to literally cut this cable, drop the 5th machine, connect the cable there, and put this T-shaped connector here. So that's bus topology. Next, star. Again, star doesn't mean that the systems have to be located something like this physically and all connected to a central device. This could be a hub or a switch. It's not the case. It's logical. Again, it's a logical topology, not physical. The topology is not dependent on the physical location of the systems. This might as well be something like this. You could have a hub and you could have all systems connected here. It is still a star topology. Next, mesh. Mesh is where you have these devices. Let's say these are routers or switches. These are connected in such a way that the systems from here to here, they have multipath, meaning let's say here wants to reach to, let's say, system A2. It could either, let me use a highlighter. It could take this route to get there, or it could also take this route to get there, or it could also take this route to get there, because the mesh, this kind of builds multi paths to, between two locations, and these are networking devices like routers and switches, and these are your laptops or computers, or networking, the servers or workstations. Next, let's take a hybrid. Hybrid is nothing but it's a mixture of other topologies. In this case, the true mesh is this. This is the mesh, but if you take this is nothing but star. That portion in red is something like this. If this is a device and you have this representing this, there's another one. Now if you see, this is same as this, so you have star and a mesh in there. That's nothing but hybrid. Wireless, it's a wireless technology. You have wireless routers and systems are wirelessly connected. That's wireless topology. Nothing, most likely you might have already have the wireless router in your house, and you might be connecting to the internet through wireless on your laptop. It's a wireless topology. Now let's take a quick look at some of the internet working devices that we'll look at 4, which is hub, repeater, router, and switches. I think I missed one thing. It's called firewall. We'll talk about this as well. Okay, hub. As we already saw in a star topology, you have hub. Now our hubs are outdated. Nobody uses it because of the bad things that could happen to your network. The biggest problem with the hub network is, let's say let me put some numbers here. Let's say if one is trying to communicate with the machine 3, then this is what would happen. Let me use yellow. So the actual network traffic from A will get to this machine or central device called hub. Then the packet would go here, here, here. That means all machines will receive the traffic, irrespective of whether they are supposed to receive or not. Even though if A is trying to send information to B while talking, the information is still sent to the rest of the machines on the that are connected to the hub as well. And now let's say if 2 is trying to send, so let me do this. Hello, meaning the actual target is 1. Sorry. 1, 2, 3. Let's say 2 to 4. So that's yellow. And take green. Oops, sorry. 2 to 4. The network traffic still goes to all systems. Now the problem with that is, if this system is trying to send a packet here out into the network, and A was trying to send packets at the same time from here, they go there, and there'll be a clash. So there'll be a data loss in this network pretty consistently, right? That's how hubs work. Next, a switch. Let me erase a few things here real quick. Okay, so let's take the case of a switch. Now with the switch, the good thing about the switch is kind of, it's very intelligent. It's an intelligent version of the hub. You can call it intelligent hub. The way this works is, let's say again, let me put A, B, C, and D. Let's say if A is trying to send information to C, the information goes till here, and then this system will figure out, hey, I want to send information to C, so it'll say, hey, you'll send packet here, here, and here. But this system responds back and says that I am C. So next packet that comes in, let me use another color. Let's say another packet comes in, and the system knows that the C is connected to a certain port on this switch, and the packets are sent here. So when in reality, when A is trying to send packets to B, or C, and when C is trying to send packets to A, the traffic is only between those two cables. That traffic will never get on here and never here. That will never happen. It'll happen the very first time, and once discovery is made, and the other systems will never receive the traffic. So the switches, as I said, they're intelligent. They know which systems are connected to the ports, and it will switch it correctly. I mean, if you were to explode it, something like this, say for example, let's say this is a switch. Let's say these are the network ports. Right. Let's say this is connected to A, this is connected to B, this is connected to C, and this is connected to D. If A is sending packets to C, it gets here internally into the switch, and then the packet goes here. This is the very first packet, goes here and goes here. When C responds, then the switch now knows, let's say these ports, I'll call it P1, P2, P3, P4. Now switch will build an intelligent table, that you call it. It'll say that, hey, port 1 is system A, port 2 is C, port 3 is B, and port 4 is D. It will build this as the initial communication occurs. Once it builds this table, then the subsequent communication from A to B will only get into port 1 and get out of port 3. So you will never see collision. So that's the beauty of the switches. Now let's take a look at routers. As the name says, it routes packets, or it routes data. Meaning, let's say you have two networks. I'll call it network 1 and network 2, and 1 and 2. Let me take an example. Let's say if A is trying to send, let me put another machine, A3. Let's say A is trying to send some information to A2. This is a switch, it's intelligent, so it goes there and information is sent to 2. What if this, because this router is connected to this switch as well, what if, think about it, if the same information goes into this router, the same information goes into this switch, and it is sent here all the way. For every time A sends to A2, the same information is passed all over the network, which is, it kills the network bandwidth, doesn't make any sense. So as long as A is trying to communicate with the systems that are within its network, which is N1, the packets will be within this network. And in particular, if A is trying to send to A2, A1 is trying to send to A2, the packets are within these particular network segment and not here. But if A1 is trying to communicate with B2 here, so what really happens is there is something called default gateway. What this is, if A is trying to communicate with B2, and if A doesn't know where B2 is, it will send the information to its default gateway. In this case, the router is a default gateway. So because it cannot find where B2 is, it will send the packet to the router, and the router has, you know, network information of both N1 and N2. It looks at and sees that, oh, the packet is being destinated to B2. The B2 is on my right hand side, and then it will pass the packet here. Now when B2 responds back, same thing happens. It goes here, and then packet is, or the data is stopped here, and the router looks at it and then determines, hey, you know, it is being sent to A1, that's on the other side. So the router makes a decision and routes the packet to appropriate network, not the system. It's a network. Once it gets to the switch, then switch will take care of sending it to the appropriate system. So that's how the routers work. Then repeaters. Repeaters are just, as the name says, it repeats and boosts a signal. If it is, if you have, you know, every cable has certain limitations on how long it can have before you lose the signal, you know, electrical signal. So if you're running cable too long, you need repeaters to boost the signal, and that's what it is used for. Firewall. Firewall, I believe we saw office network where you had, you know, in the office you had, you know, a router, and you had a bunch of systems, switches, but before it went to internet, you had, right in the middle, you had firewall, right? So that firewall, what it does is it protects your office network, or it protects your LAN, or it protects your network. You can configure your firewall in such a way that you only allow certain traffic to go out and certain traffic to come in. And by default, in your home routers, you know, it's like all in, all out. You can, anybody can come in, anybody can go out, or everything is open. You can configure the firewall in such a way that only certain traffic goes out and certain traffic comes in. You know, that's the use of the firewall. It's kind of like a gate for you, you know, a security gate. Okay, now that will conclude our second part of networking concepts. And to summarize, we looked at types of networks, we looked at network topologies, and we looked at some of the internet working devices. Thanks for watching.